Hello, this is part 16 of our Building with Claude API series. And in this video, we're going to talk about RAG, which stands for Retrieval Augmented Generation. Now, even before we get into this topic of RAG, if you have not heard already, I'm facilitating a one-day live online workshop called Intro to AI Engineering with Claude API. This workshop is going to cover pretty much most of the topics that we have discussed in this series. If you would like to have a live human, which is me, introduce you to these concepts by means of having these lively discussions and engagements with a peer group of people, you should definitely register. You can register by means of sending me a message on WhatsApp. So this is my number. Make sure you connect with me and register any Saturday this July. It'll be happening from 9 a.m. to 5:30 p.m. I would love to facilitate you as you get introduced into AI engineering with Claude API. All right, so let's get back into the topic, Retrieval Augmented Generation. We know that Claude has intelligence based on its training data, and by means of the tools that we connect to it, it can even fetch additional data and give us some inference. What if you want Claude to fetch information from your source of truth? Let's say you have some sort of a document that is internal to your team or your company, and you want Claude to refer to that document to give answers rather than getting information from its own training data or elsewhere from the internet. That is where RAG comes in handy. It basically is a technique where we fetch some additional information and add it to the prompt even before we give it to the AI. We can think of it in this way. Let's imagine we want to build an AI customer support agent for a dentist. From the dentist, we would get their policies and the way they work, the operation hours, maybe their refund policies, the kinds of different services that they provide. All of this would be an internal document that comes from the dental clinic. Now, this information, since it's personal to the business, to that dental clinic, it would not be available in Claude's training data or elsewhere in the internet. Now, imagine a new patient wants to know about the operating hours of this particular dental clinic. So the patient would be talking with an AI chatbot to get that information. And this AI chatbot is going to be powered by Claude. Imagine this patient wants to know the operating hours of this dental clinic. Now, in order to answer that question, whenever the patient asks for the things like the operating hours or some policies of the dental clinic, in our AI bot, you just take the entire document and attach it to Claude as part of the prompt, and Claude will be able to kind of figure out the answer because it has context from this document and it can return back an intelligent answer back to the patient. So that is definitely doable. It's just that imagine this document is really big, and anytime the user is asking about the dentist, if you're going to append this huge document as part of the prompt, it's just going to be unnecessarily expensive token wise. So that is where this idea of RAG comes in handy. Now, what if even before you go to the AI, whenever the user asks for some information in your application, you go and fetch just the relevant chunks from this document, not the entire document, just the appropriate chunks, and you append only those relevant chunks into the prompt before feeding it to Claude. So that will greatly optimize the amount of tokens that Claude is going to consume, right? So that essentially is the idea. But the challenge here is, how do we know what is the relevant chunk from this document that you need to append into that user prompt? The user prompt, again, is going to come in natural language. So from that natural language, you need to understand what the user wants, and you need to find the relevant parts of this document to append to the user prompt. So in order to achieve this, we need to somehow be able to chunk this document into smaller parts. Like somehow we need to figure out what are the different sections that are there in this policy document, and then we need to figure out a way to search these chunks based on the user prompt that comes in. So that is basically the idea of using Retrieval Augmented Generation. You just are augmenting the prompt that comes from the user with the relevant chunks. And the challenge is, how are we going to chunk this document and how are we going to search through these chunks based on the user prompt that comes in? So let's look at some code to see this practically in action. Over here, we have these two files. One is the Jupyter notebook where we're going to actually run the code, and the other is this markdown file. All right, so this is the mock dental clinic that we're going to be using. Okay, so it's like a fictitious dental clinic called Bright Smile Dental Clinic, and this document contains information regarding its operations, policies, terms and conditions, basically everything that a customer support agent would need. And we can see that this particular document itself is about 197 lines, which is okay, but you can imagine companies and businesses having these kind of documents which are thousands and thousands of lines long. So this is the document that we are going to use as a source of truth for our AI customer support agent. And over here in our Jupyter notebook, what we start with is creating this system prompt. Okay, so this system prompt basically informs Claude that it is a helpful customer support chatbot for a dental clinic called Bright Smile Dental Clinic. And then we also specify that it should respond only from the dental clinic policies material and not from any other sources. Okay, so that's very important. And we explicitly state that it should not pull any information from its own training data. And if for particular questions the information is not provided in the prompt, then it should just say that it doesn't have the necessary information in a polite manner. This is the instruction. This is the system level prompt that we are giving to Claude. Now with this, let's run the Claude API and see how Claude will answer for a common support question. The question that we're going to ask Claude is, what time does this clinic open? And in the prompt itself, see over here, this is where we are including the dental clinic policies text. Okay, so here it is up to us whether we are going to feed the entire document or those chunks that we talked about. As a first step, what we'll do is we just feed the entire document, literally this entire markdown file, as part of the prompt that goes into Claude. In order for us to run this, we actually need that dental clinic policies text, right? We'll open the dental clinic policies markdown file. We'll just basically read the file and we'll put all its content into this variable called dental clinic policies. And that's the variable we are using over here to feed into our user prompt. Let's even print out the messages to see what is the prompt that we are actually going to give to the Claude API. And you see that it's quite a big prompt, right? Because we're literally feeding this entire document as part of the prompt. You see over here, the role is user, and we can see in the beginning the actual user prompt that came in, which is what time does the clinic open? Just to answer it, we are like literally including this big document, which is like nearly 200 lines long, to the prompt, right? And this is the prompt that is going to go into Claude API request. Okay, so let's see what result we get out of this. And we can see that Claude is able to answer the question. It does tell us that Monday to Friday it's like 8 a.m. and Saturday is 9 a.m. and it got information with regards to all the different branches of this dental clinic and gave us a relevant answer. But what was the cost of doing this, right? If you come down and see the input tokens that were given to Claude API to get us this answer is 3,422 tokens. Okay, and you can just imagine with larger documents, the token size is just going to be even bigger, right? Which is unnecessary, because if we can just figure out a means to get that chunk of text from this document, like for example over here in this document, you could see, like as a human, if I look at the table of contents, I know that there is something called opening hours, right? So probably that is where I would look for the information with regards to the opening hours of the clinic. And there is also booking an appointment section which might be relevant. Now, if instead of feeding that entire document which we see here, what if we could just take this chunk, right? If we can just take this chunk of text and if we can add it over here, then that will be highly optimal, right? So how do we go about doing that? Like, we can't go and manually do this every time, and parsing this entire document with just Python is just going to be unnecessarily expensive. So how do we do this, right? Now, that is where those two things that we talked about come in place. One is chunking and the other is searching. For handling both, there is a lot of art along with science. You can actually do these two things, either the chunking or the searching, in n number of ways. So it's totally up to us to be creative and implement it how we seem fit for our application. Let's start with chunking first. So over here, what we have decided to do for our use case is we're going to chunk it by section. So in this case, it really falls into place because it is actually like a policy document and it has all these nice sections. You can see that it is like properly structured and organized. We could leverage that. So what we are doing here to chunk is we're just chunking it based on the headers. Okay, so each section, like literally, is going to be a separate chunk. So this first part is going to be its own chunk. Maybe the table of contents will be another chunk. This about section will be another chunk. Locations will be another chunk, and so on, right? So let's do that. Let's first chunk it based on section. Now, this is not the only way that you can chunk a large document. You can even chunk based on the number of characters, if that makes sense. Because if you're just working with a totally unstructured document which doesn't have like these nice sections and so on, how will you even like chunk them? You can just chunk them based on like character count. Maybe like the first 100 characters you put it in one chunk, the second 100 characters you put in the second chunk, and so on. So there are a lot of these trade-offs that you need to do as you build this RAG flow. But for our use case, just chunking them based on these headers works. So let's do that first. So I'm gonna run this now, and it's chunked. And when we print the chunks, we can see that each of the sections of the document, right? So this is the first section of this document. This part is printed over here, and then the next chunk is basically the second section, and so on. That's how the entire document has been like split into these respective chunks. Now the second step is, how are we going to find the relevant chunk based on the user prompt? Semantic search enables us to search text based on its meaning. So here what happens is, imagine we give this text of what are your operating hours. So the semantic search is done in two steps. The first step is, so this string, right, is converted into a bunch of numbers. So each of these words are like converted into these numbers, right, like this array of numbers, and these numbers get assigned by means of the meaning of each of these words. Okay, so that's the high level overview of how this embedding works in semantic search. So we don't need to go deep into this. We are going to be using another tool called Voyage AI. Okay, so it's another tool from the MongoDB company which helps us to set this up. There are other services available as well, but in the Claude course itself, the official course itself, they suggest that we make use of Voyage AI. So we will be using that. Whichever service you use, the idea is this. So the string is converted into these numbers, okay, and these numbers hold meaning, and based on that it will be able to figure out what are the other strings which are closer. For example, in this case, when we have another string such as opening time, okay, so here you see this word opening or time is not over here in this sentence, right? So in this sentence of what are your operating hours, the word opening or time is not there. But even though it's not there, if you create the embeddings for opening and time, you would create these numbers. These numbers would be close to these numbers in the model that we use. And because these numbers and these numbers are closer in the multi-dimensional space that this particular embedding model has, this will be associated with this, right? So that's essentially how the search works. So when you say what are your operating hours, it will find the text that has the strings opening time and return it to you, right? Because the numbers of opening time and the numbers of what are your operating hours will be close to each other in that multi-dimensional space of like a model such as the Voyage AI tool. This is a bit of a very high level overview of this semantic search mechanism, and we'll make use of this to find the association between the user prompt and the appropriate chunks of the policy doc. Okay, so let's do that now. Over here we have already created the chunks based on the sections of this markdown file. So the next step, we're going to create the embeddings. In order for creating this embedding, right, what we are going to do is we're going to make use of this AI tool called Voyage AI. Okay, so this is how you would install it in a Jupyter notebook, and then you just need to import Voyage AI. Now you would need to have an API key to access this, just like how we set it up for Anthropic. We would need to set up an API key for Voyage AI as well. Okay, so let me show you how to do that. Okay, once you log into Voyage AI, you will find a section called API keys. Just click on it, and there, click on create new secret key. Give a name for your project, and then click on create secret key. So that's going to create the key for you, which you can just put it in your like .env file. Okay, just like how we have set it up for the Anthropic key. The environment variable should be this. Okay, so just like how for Anthropic we had Anthropic API key, for Voyage AI it's Voyage API key, and you just paste the entire key over here. That's it. And make sure you don't share this API key with anybody else, because it is associated with your billing, and you will need to provide like a payment mode, like a card or something, to start using it. Just like how for the Anthropic API we set up a balance. Here again you need to set up a balance. You can start with $5. So that's what I have done, and that will be ample for our use case. So once the .env file is set up and you've loaded the environment variables, we can now import Voyage AI, and then we create the client over here. So this is how we create create the client, just like how we did for Anthropic. And now we have this method called generate embeddings. So this is that step that we talked about earlier of converting that text into numbers so that we can figure out where those numbers live close with each other to get the meaning. So all we need to do is just like get the text, whatever we want, and pass it into this Voyage AI client. And this will return back to us a result, which will be the vectors, which will be the numbers. Okay. So let's just try this out and see what we get. Okay. So we already have these chunks, right? What we'll do is we'll call this generate embedding with a chunk. Okay. So we're just giving the first chunk alone to generate the embedding for it. Let's see what we get. And here you have it. You see a bunch of numbers, right? All these numbers represent the first chunk, is basically this part, right? This initial part is being represented by these numbers. Similarly, for every chunk, we'll be generating these embeddings, which are these numbers, which hold the semantic, the meaning of those respective characters. Now, the numbers that we see, right? Like all these, numbers, we would still need to hold it in some sort of a database or some sort of a data store so that we can search. Say, for example, if all the embeddings are created for the policy document, like when the user gives this input of what are your operating hours, we can convert this also into an embedding, and then for us to search the embedding that came in and the embedding that is already there in the policy document, we would need some sort of a data store. So that's where vector databases come in place. So here what we have done is we have just set up this simple vector index. You can get this code directly from the RAG and agentic cert of the official Anthropic Academy building with Claude API course. So we're just going to leave this as a black box for now. Okay, so we're not going to go and discuss about vector databases or vector indexes now. We'll just make use of this implementation to understand RAG better. So here, since we have that vector data store, what we'll do is we will just give this, generate embedding method that we have here. So this is the way we want the embedding to be created. It's essentially using the Voyage AI client. Now we give this callable into this vector index, and anytime it wants to create those embeddings, like be it for those respective chunks or for the user prompt, it's just going to make use of this function. And then with that in place, we can add those respective chunks into the vector data store. Let's run this code, and now those respective chunks have been made into numbers. The embeddings for those chunks have been created, and it's all present inside of this data store. Since we have all those numbers, right, all those embeddings in this data store, we can search for similar meaning chunks. So that's what we're doing here. So we are saying, what time does the clinic open? Because this is the user prompt that is coming in, right? So this basically is the prompt. What time does the clinic open? So whatever the user is giving as prompt, we just, first of all, we would create an embedding out of this. Okay, so that's what this vector index internally will do. So it will convert this string into numbers. Okay, so this, you see the user prompt that came in, converted into numbers, and then it will search against the data store of the entire document, which again has been broken down into smaller chunks. Now all these respective chunks, right? So it's all in the vector store, which is basically this guy, right? So over here in the vector store, since all these respective chunks in their numerical form, like as numbers, is present here. So when we ask it to search, it's going to just do a bunch of math to figure out what are the chunks which are closest to this number. So that's essentially what this line is going to do. And we can see that we get back two contents because we even specified what are the two most closest chunks to this particular string. So we see the first thing that we got is this section, opening hours chunk. We got this back. Perfect. That's amazing. And then the second chunk that we got back is the booking and appointment chunk. So here, this guy. Perfect. So these are the, most relevant chunks to the given query, right? To the given string. And by means of using the Voyage AI embeddings and storing it in some sort of a vector DB that we have, we are able to find the chunks that are semantically close to the given user prompt. Perfect. And now what we can do is we can very easily get just the content of the first chunk and the second chunk and append it to the user prompt, right? So that's essentially what we're doing here. So here we are looping through the result and we're getting those two chunks. In this case, there's just these two chunks that is all added to this string called dental clinic policies. Print out dental clinic policies, and you see in fact that you have the opening hours chunk and the booking and appointment chunk. Perfect. Now this, in contrast, is much more relevant, right? This particular string that we are going to pass into the prompt, rather than before when we had just open the entire file and like loaded everything into it, right? So that's like not at all ideal. So here we got just the relevant chunks and we're going to append the user prompt with this. And because of this, you can print this messages now and see it's much more manageable. If you remember in the beginning, we had this huge messages list, but now it's like, just the relevant information is part of this user prompt. And now let's run the API call. Let's run this now. And we see that yes, here again, we get a response as before. It tells us the timing from Monday to Friday and also the Saturday timing. And it even talks about all the different branches. So the answer is spot on, perfect. But what changed here is the input tokens. Previously, we had used over 3,000 input tokens, but here it's just like 4,407 input tokens. So that's a real contrast. This concept of RAG is something that we do even before we go to the primary AI that we use. For example, here, even before we made an API call, all of this work of chunking, basically breaking down this big document into respective chunks and creating those embeddings and storing them in a vector data store, all of that happens upfront so that we can search for the appropriate chunks based on the user prompt. All of this happens before we even give this to the API, because we are essentially augmenting the prompt, the user prompt that goes into Claude. So yeah, so this is basically like the idea behind RAG, and this is how you would go about setting it up. This is just an introduction to this powerful concept because you can build some really sophisticated chunking strategies and also searching strategies. Both chunking and searching is a computer science problem, right? This is something that we have been dealing with as software engineers like forever, right? So, it's more of an art than science. But once you have set up a relevant chunking strategy and a relevant searching strategy, you get very good returns because, the cost of running your application dramatically is optimized, because instead of like 3,000 odd tokens, we saw that, it's nearly like a 10x improvement, right? Because the number of input tokens is greatly reduced, and also we only feed in relevant chunks into Claude, because over here itself we do the chunking and the searching and like only feed things that are relevant to Claude. So this was RAG. Hope it was useful. And if you're looking for a live online one-day workshop with regards to these topics of getting introduced to AI engineering with Claude API, definitely connect with me in my WhatsApp. I would love to facilitate you and be part of your journey into AI engineering. Thanks for watching, and follow along if you're exploring AI for your workflows.